All right, everyone. So we are back to reviewing for our midterm. This is the second video. The focus here is going to be on some force questions, and maybe we'll get to energy. I might have to make a third video. We'll see. All right, question 10. Use the table below to fill in the sentences below. So you want to notice the pattern here to see what is the connection between force, mass, and acceleration. So the first one is for a constant force, as mass increases, acceleration blank. Well, as mass increases, we can see you want to focus on these two right here. So I'll just put a box around here. So, and I probably could have given you a lot more data, but I think you only need two pieces here. When the mass is increasing, but force is constant, you want to say what happens to the acceleration. Well, we went from 2 down to 1.3. So for a constant force, as mass increases, acceleration decreases. And then for a constant mass, as force increases, acceleration blank. All right, well, you have a constant mass for these two, and you have a force increasing. So what happens to the acceleration? Well, you go up from 1 to 2. So we would say it increases. And again, I hope some of this makes intuitive sense. If you're going to push something harder, it's going to move faster, and you're going to accelerate it. On the flip side, heavier objects are harder to move, so heavier objects are going to be harder to accelerate. All right, number 11. So the key to this one was you wanted to use the equation F equals ma. Or sometimes we write it as F net equals ma. Because really it's the net force. It's the net force that determines the acceleration of the object. Sometimes we shorten it to just F equals ma. So you might see either of these in a textbook or in a video or something like that. All right, so in this case, we want to do, I'll just do one example here. So here we want force as 75 and mass as 100. So if we plug that into this equation here, we'd say 75 equals 100 times A. And if we want to figure out A, we need to get rid of this 100. So we're going to divide both sides by 100. And that means that your acceleration is going to be 0.75 meters per second squared. So that's the number that should go here, 0.75. I'll quickly do this one as well. So force is mass times acceleration. So all you had to do here is you just need to multiply these two numbers, mass times acceleration. So we multiply these two to get this. So 2.5 times 200 is 500. All right, for the next one, we have Mr. Farah. You guys know him. He's moving a large table with a big machine on it, as he would. He pushes really hard, as he would, with a force of 700 newtons. The force of friction is 650 newtons. You want to find the net force acting on the table machine, and then you want to find the acceleration. So it's always useful to draw this out. So we have maybe, we can just draw it as a box. And we have Farah pushing with 700 newtons this way, but friction is resisting us at 650 newtons this way. Okay, so the net force is adding up all your forces together, right? So F net, when you have multiple forces, F net is F1 plus F2 plus however many forces you have. In this case, we only have two forces. We have 700, and then we have, we're going to add a negative 650. Now, the negative 650 is because this is going to the left, so it's a negative force. And if you add these up, you'll get 50 newtons. So the net force is 50 newtons, which means that Farah has enough force to make this thing move, and it's going to accelerate. So that kind of leads us to the next question. If we know the mass, what is the acceleration of this table and machine? So the next thing you want to do is you want to take this net force, and we're going to use this same equation that we just used before, because now we know our net force and we know our mass, and we're trying to find acceleration. So we have our net force is 50. Our mass is 220, and we're trying to find acceleration. So running out of space here, I'll try to fit this in. So we have 50 is equal to 220 times A, divide both sides by 220, and our acceleration is 50 divided by 220. I'll try to do that in the calculator really quickly. 50 divided by 220. So 0.2, we'll say 0.23 just to round it up. So 0.23, and that's in meters per second squared. Okay. So those would be your two answers there, the net force, and then once you know the net force, you could find the acceleration. All right, I think we have enough time to do the energy questions. Let's just quickly do these energy questions here. So actually this one's related to the conservation of energy, and then this one's related to calculating um, calculating energy or power. So number 15, you have a block attached to a spring. The spring is stretched and then released. It slides back and forth. And so the table shows all the different types of energy, and using the law of conservation of energy, calculate the thermal energy. So the key idea here is that conservation of energy says that energy should not be created or destroyed. That means that your total energy should not change. So if your total in the first moment is 0 plus 8.9 plus 0, which is 8.9, so we just added all these up together, your total should be 8.9. All right, so that means that your total in the second moment should also be 8.9. That's what it means for energy to be conserved. All right, so if we know our total energy, and we know that all three of these should add up to 8.9, we can figure out what this missing number is. So it would be 8.9 as my total. It's going to be equal to 1.6 plus 2 plus some missing number, some thermal energy. So I have 8.9 is equal to 3.6 plus some thermal energy. And now I just need to subtract 3.6 from both sides. 3.6, 3.6, and I'll get my thermal energy is, what is that? 5.3. 5.3. Okay. All right, and then last question here. The key idea here is power is equal to the change in energy divided by time. All right. Um, so maybe these other ones might be easier to do because you just do 400 divided by 4 or 800 divided by 6. These other ones you might need to kind of rearrange the equation. So let's do the easy ones first. Um, you just do 400 divided by 4. I'm just going to write it out though. So let's say we're trying to do this one here. So this one is power is equal to change in energy divided by time. So that would be 400 divided by 4. And that equals 100. 100 watts. All right, so divide energy by time. 400 divided by 4. 800 divided by 6. All right, now for the other one, we're just going to rearrange this equation to find the energy. So we know that power is equal to the change in energy divided by time. Another way you could write this is if you multiplied both sides of the equation by t, I can multiply by t over here and multiply by t over here, and I would get power times time is equal to my change in energy. All right, and that's how we're going to find the energy for this question. So let's just plug in our numbers here. So we have 10 times 5. Let's say we're doing this one, right? So my power is 10, my time is 5, and that's 50. All right, so 50 joules. And again, to kind of check your answer, you can just do 50 divided by 5, and that is 10. All right, and I'll do one more real quick. So number 19. Efficiency. Remember that efficiency is your energy out divided by your energy in, or your power out divided by your power in. So let's write that. So efficiency is equal to output divided by input. Again, there's a lot of useful equations that were given to you on the back of the midterm review, and those equations will be given to you the day of the midterm as well. So real quick, if I was going to do the car engines aren't actually very efficient. They're usually somewhere around like 25 to 35% efficient. We can calculate the efficiency for this one. We do 4,000 divided by 12,000. Our output is 4,000. Our input was 12,000. So you just divide those two, and that should be 0.33. Now again, efficiency is usually in percentage form, so we would just say 33%. So this efficiency would be 33%. All right, so I'll stop there, and good luck with the midterm.